So hi there everybody. So in this another video for fundamentals of mathematics, we're going to talk about more in our series in the fundamentals of number theory, and we're going to have some exercises, okay, in knowing if it is a prime or a composite number. So I have here 10 numbers, okay, or 10 integers, and we're going to determine if it is prime or composite. So we're going to write P if it is a prime number, and if it is a composite, so we're going to find all the prime factors. And we're going to use that using prime factorization or complete factorization. I'm going to make use of the factor tree here or the successive division, whatever is going to give us more specific easy time. Okay, so let's start with number one. So for number one, is it prime or composite? So we're going to ask. It's not. We're going to go back to our divisibility rules. I hope you have learned that already, or you have somehow mastered it at least, or practice it at least. So it's not divisible by 2 by obvious reasons. It's not an even number. It's not also divisible by 3 because adding them up will not be a multiple of 3. That's going to be 2 only. It's not also divisible by 4. It's not divisible by 5. It's not also divisible by 6 because it is not both divisible by 2 and 3. It's not also divisible by 8, not also divisible by 9 and by 10. So let's stop there and we can say, and maybe you can check it, that 101 is a prime number. Okay, 101 is a prime number. Actually, 101, just a trivia, is the 26th prime number. It's a 26th prime. Okay, so it's the 26th prime number. So that's the 101. Since there are 25 prime numbers between 1 and 100. Okay, so how about 963? Is it divisible by 2? No. Is it divisible by 3? Let's check. 9 plus 6 is 15, plus 3 is 18. Okay, so since adding the digits will give us a sum of 3, therefore this is not prime. So meaning we need to find all its prime factors. So we're going to make use of the factor tree here. Let's do this. 963. So this is divisible by 3. So what is left? Divide 963 by 3. So we have 3, 2, 1. 3 to 1 is still divisible by 3 since adding them will give us 6. So divide this by 3, we have 107. Next question is 107 a prime number? Okay, is 107 a prime number? So we need to find a lot of ways to know if it is prime, but we know that it's not divisible by 3, it's not divisible by 4, it's not divisible by 5, or by 7, or by 8, okay, or by 9. So let's try to consider that this 107 is prime. So let's have it. The prime factors are 3 times 3 times 107. 3 times 3 times 107. Okay, how about 288? That's it for number 2, rather. So number 288. So we can see that this 288 is divisible by 2 since it ends with a prime number. So, or by an even number rather. So we have a 288 divided by 2. So we have 144. 144 is still divisible by 2. I'm going to put it here. 2 is going to give us a 7. And this is going to give us 2. Still divisible by 2. So we have 2. This is going to give us 3 and 6, 36. Divisible by 2 still. So we have 1 and 8. By 2 still. 2 rather. 2 and 9. So this is 3 times 3. Rather, we can use the canonical form here. So this can be written as, for number 2, 3 squared times 107. For number 3, we have 1, 2, 3, 4, 5. 5, 2. So we have 2 raised to 5. 2 raised to 5 times 3 squared. 2 raised to 5 times 3 squared. Next, how about 37? Is 37 a prime number? So let's try to check that. Is it divisible by 2? No. Is it divisible by 3? No, that the sum is 10. Is it divisible by 4? No. The nearest value for 4 is 36. Is it divisible by 5? No. 6? No. 7? Nah. The nearest multiple of 7 is 35. That is 7 times 5. It's not also divisible by 8. Also by 9 because that's 36 if it is 9. And also by 10. So we can say that 37 is a prime number. Okay, so the 37 is a prime number. How about 72? Is 72 a prime or composite number? So actually, you can see it here. Okay, that 72 can be written as 2 times 2 times 2 times 3 times 3. So from this answer here, we have, so it's not prime, but it is 2 times 2 times 2. We have 2 cubed times 3 squared. That's 72. How about 650? So clearly it is divisible by 2 because it ends with an even number. So let's try the factor 3 again. 650 divided by 2, we have 325. And then this is divisible by 5. Okay, let's use that. So we have 6, that's for 30, and we have 5, 65. Okay, so 30 and then 25. And then let's have, again, it's divisible by 5 again. This is 1, this is 3. And then 13 is a prime number already, so we can write this as 2 times 5 squared times 13. Okay, how about number 7, 4085? So it ends with 5, so therefore it is divisible by 5. So we have 4085. Let's divide this by 5. 40 is 8. 8 is just 1. We have 35, which is 7. Okay, so let's check. Is this divisible by any number? It's not divisible by 2. Is it divisible by 3 though? 8 plus 8 is 16. No, it's not. Is it divisible by 4? 17 is not divisible. Yeah, the 17 is not divisible by 4. Also not divisible by 5, not by 6. How about 7? Twice the first number. So twice the first number is 14 minus 81. It's gonna give us 7 bar 3, which is actually 67. Is 67 divisible by 7? No, it is not. Okay. How about if it is divisible by 8? Well, no, it's not also divisible by 9 and also by 10. So let's be contented to say that 5 times 817. If this is not a prime, if 817 is not a prime, please correct me for that. Okay. Number 8. Obviously it's not a prime because it ends with 0, so therefore can be divisible by 2. So 1240 divide this by 2, so we have 620. Okay, 620. This is still divisible by 2, so we have 2 times 310. This is still divisible by 2, so we have 3, sorry, 2 rather, 155. Okay, 155. This is divisible by 5. Maybe we can do it like this. I'm sorry about that. 5, and then this is going to be 31. Okay, 31. And then let's believe the 31 is a prime number. So what we can write this as how many? How many fives? Oh no, we started here rather. So we have 2 times 2 cubed times 5 times 31. Okay, times 31. Okay, how about 81? So we know this as not a prime because this is 9 squared. So 9 squared, 81 is 9 squared. So we know 9 squared as 3 times 3 times 3 times 3. Okay, so we have 4 threes to be written there. Since 9 is 3 times 3, so 2 nines is 3 times 3 times 3 times 3, or simply 3 raised to 4. How about 47? Let's end it here. 47 is a prime number. Okay, to say that very, very clearly, very, very straightly. Okay, so yeah, that's it for our these exercises for 1 to 10. 1 is a prime, 2 is not, 3 is not, 4, yes it is a prime, 5 is not, 6 is not, 7 is not, 8 is not, 9 is not, and 10 is a prime number. Okay, and that's it for this video. I hope you have learned something from there. In our prime factorization or complete factorization, from our prime or complete factorization videos, and also for our videos in prime versus composite numbers. So thank you very much for watching. Don't forget to like and subscribe. See ya.